First, so we'll start with a discussion of the pop quiz, which is related to topic electrolysis and the modes. This was one of the pop quiz I shared in the week, and the second pop quiz was related to atomic structure and bonding that we'll discuss in the next session. The first one, an electrolysis experiment, is done using a carbon electrode. Carbon electrode means the inert electrodes are there. Hydrogen and oxygen are formed. What are the electrolytes? So for this, first you will identify the ions. Like if you have aqueous copper 2 sulfate, so what are the ions? It will have copper ion, it will have sulfate ion, and because it's an aqueous solution, so aqueous solution must have hydrogen ion and hydroxide ion as well. H plus ion and OH minus ion. So anode and cathode, like anode is a electrode with a positive terminal anode and electrode with a negative cathode. So which ion will move there? Because we have two positive ions, copper and hydrogen. So less reactive ion will move. So in this case, copper is less reactive. So copper will move towards cathode. And for negative ion, we check the amount, but sulfate, nitrate, and carbonate never move. So this sulfate will not move at all. So what will move? The hydroxide will move. So hydroxide will move. The product will be oxygen. There will be oxygen because of hydroxide. But the other product won't be oxygen, hydrogen. Other product will be copper. So copper and oxygen are the product. So it cannot be A. When you check option B, if you're doing concentrated hydrochloric acid electrolysis, you have two electrodes are there. Hydrochloric acid means it contains H ion, it contains Cl ion, and aqueous HNOH ion. So hydrogen ions are attracted towards cathode because they're same here, but it's a concentrated. So we check the amount. Chloride ions are more and hydroxide ions are less. So chloride ion will move towards NO. So as a result, what will happen if a chlorine is moved towards anode? So one of the product will be chlorine, another product is hydrogen. But we want hydrogen and oxygen as the product. So it cannot be B. When we check option C, aqueous dilute sodium chloride. So we have two electrodes, anode and cathode. The ions which are present, there will be a sodium ion, there's a chloride ion, there is a hydrogen ion and hydroxide ion. For the less reactive positive ion will move, so hydrogen will move here in this case, which is less reactive towards the cathode, so we'll get a hydrogen gas. And it is dilute solution, dilute aqueous, so means hydroxide ions are more. So if hydroxide ions are more, the hydroxide ions are attracted towards anode. So when hydroxide ions are moving there, a result, the product will be oxygen. So electrolysis of a C is giving us hydrogen and oxygen as a product. So it should be a dilute aqueous sodium chloride. Is it clear, this one? In question 2, concentrated aqueous copper 2 sulfate is electrolyte using a copper electrode. So if you have copper electrode, the anode made up of copper, the cathode is also consists of copper, and the electrolyte, what it contain copper ion, sulfate ion, it contain hydrogen ion and hydroxide ion. So when we check the reactivity, copper is less reactive, so copper ions are attracted towards the cathode. So when copper ions are attracted towards cathode, the copper ions will gain 2 electron, it will turn into copper atom and it will stick to the cathode. So which ionic half equation describe a reaction take place at cathode? The copper ions from the electrolyte are attracted towards cathode and they will take those electrons from the cathode and turn into copper atom. So D should be the right answer. In question 3, the diagram shows electrolysis of concentrated hydrochloric acid and concentrated aqueous sodium chloride using the inert electrode, or you can also say the carbon electrode or graphite electrode. So if you are doing the question is at which electrodes is a hydrogen produced? So in a concentrated hydrochloric acid, there is a hydrogen ion, there is a chloride ion, hydrogen ion, and hydroxide ion. So hydrogen ion is common here. So as the hydrogen ion is common, it is attracted towards the electrode 2, thus negative. And if you are using a sodium chloride aqueous, so concentrated sodium ion, chloride ion, hydrogen ion, and hydroxide ion. Here hydrogen is less reactive, so it will be attracted towards cathode as well. So electrode 2 and electrode 4 both will liberate or discharge. Hydrogen will be discharged. So electrode 2 and 4, so it match with option D. In which diagram, question 4, in which diagram the movement of ions and the electron during electrolysis of a molten sodium chloride is correct? So first, if we have like a supply is there, so electrons always move towards the cathode and electrons are moved out from anode. This is the movement of electron. So they move towards the cathode and they move out from anode. So if it's a like if A was the answer, electrons are moving towards cathode and electrons are moving out from anode. So flow of the electron is, because flow of electron is correct. Even for B, when you check for B, the flow of electron, like electrons are moving towards cathode and electrons are moved out from anode. C, it is wrong because C, it is given electrons are moving towards anode. That is wrong. D also, it is wrong. So either A can be an answer, B. Then when you talk about the ions, what will happen? The sodium ions are positive ions. So positive ions are attracted towards cathode, the negative plate. So sodium ions are positive ions. So positive ions are attracted towards the negative plate. And anode is positive, so this will attract the negative ion. So chloride ion will move towards the anode and the sodium ions are moved towards cathode, and the movement of electron is from battery towards the cathode and from battery or a supply towards cathode, and from anode it is out. So option A will be the right answer. Molten sodium chloride and concentrated aqueous sodium chloride are electrolyzed using a platinum or a inert electrode. What are the products at negative electrode cathode in each electrolysis? So if we are doing the electrolysis of molten sodium chloride, what are the ions present? It contains sodium ion and chloride ion only. And sodium ions are positive ions, so positive ions are attracted or discharged towards cathode. So molten, we will have sodium. But aqueous concentrated, what are the ions? It contains sodium ion, it contains chloride ion, and it contains hydrogen ion and hydroxide ion. So sodium ion and hydrogen ion both are positive, but less reactive, will move towards cathode. So in this case, the hydrogen ions will move towards cathode. So if we are using concentrated aqueous sodium chloride, so then hydrogen is there. If we use molten, then it will be sodium. So C will be the right answer. Question 6 is related to the moles. You have in the question, you have 20 cm cube of 20 cm cube sulfuric acid reacted with 25 cm cube of 0.2 mole per dm cube sodium hydroxide. Calculate the number of the moles. So how to get the number of moles? Number of moles is concentration into volume. So concentration is 0.2. And what about the volume? 25 cm cube we divide by 1000, so 0.025. So 0.025 multiplied by 0.2, what's the answer? 0.2 times 0.025. So this will be 0.005 moles. Then determine the moles of sulfuric acid, because the first part we solve by using a formula. The second one we'll use a ratio. What ratio we'll take? We'll take a ratio between sodium hydroxide and sulfuric acid. So according to equation H2SO4 and NaOH, the ratio between them is 1:2. So if we have 0.005 moles of sodium hydroxide, how many moles of sulfuric acid? X. So it will be 2x is equals to 0.005, or x is 0.005 divided by 2, which is equals to 0.0025 moles will be there. Now we need the concentration. To get the concentration, same formula, because the first part we solve by formula, then we use a ratio, and again we'll use a formula. So moles equal concentration into volume. The moles of sulfuric acid are 0.0025. The concentration we don't know, and the volume of sulfuric acid is given in the beginning of question, which is 20 cm cube, or divide by 1000, 0.02 dm cube will be there, because the volume should always be in dm cube. So this is multiplied, other side will be divided, so 0.0025 divided by 0.02. We'll get the concentration in moles per decimeter cube. 0.125. So this will be 0.125 moles per decimeter cube. So whenever a moles question is there, first part is by using formula, second is by ratio, and the third again we'll use a formula. Usually this is a pattern, but there may be like exceptional questions are there. It's not like all questions solve in this manner, but most of the questions are in this manner. So this was a pop quiz, assessment quiz, which was related to topic electrolysis and the moles.